So what I'd like to do is give you some pictures, give you some ideas about keyboards. We won't get every bit of information about keyboards today, but this is a set of slides that I think will give you a good overview of keyboard technology and keyboard ideas that build on what Tex gave us a couple of weeks ago about Unicode and ways the characters are actually represented. First of all, for using a language online, we need several things. We've talked about text representation and a little bit about display technology and fonts. Today, we're going to focus on input tools, which are ways to create and edit and manipulate text, generally in an application. The details of the applications, of course, we're not going to cover because there are so many. But the input tools idea is a general concept that can be used with almost any application, either on mobile or on desktop or in browsers. One thing that's important to understand is that keyboards are not typewriters. Now, when I was a farm kid back in high school, I was rather unusual in the sense that I was the only boy in the typing class when I was 16, because typing at that time was something that was done only by people who were either going to be working in an office or people who were going to be typing up papers in college. And I probably took a little bit of razzing from my friends for taking typing when many of my friends were not going to be going to college or not going to be farming. But the concept of a physical keyboard was that one has a key. It's connected to a piece of metal that actually moves and puts a piece of ink on a piece of paper. And I realized the word type, the verb type, probably comes from typewriter as opposed to type, which is the metal piece that actually makes the imprint for printed materials. And typewriters got more advanced. The first typewriters only had one level, but people very quickly realized that at least in Western languages, we needed uppercase and lowercase. So they added the concept of a shift, and that shift would then select a different piece of the metal tab that flew up onto the ink. And so we got upper and lowercase. That's why we have the shift keys on our keyboards. You also might note that the keyboard that I have added here is not an English keyboard because the M isn't the same place as you might see it on your English keyboard. But the concept of a base set of physical keys to touch plus some modifiers, in this case the shift, is something that we all understand and kind of think about when we're actually working with a physical keyboard on a laptop or desktop. We think about there being a real connection there. Well, there is a connection, and the connection can be set up for different kinds of keyboards. Here is an AZERTY keyboard, which is a physical keyboard used for French. Because French uses different letters in different frequencies, they've come up with a slightly different arrangement of the Latin letters. And they have a few other things with accents and other characters. But the concept of a physical keyboard with particular keys that do particular things is definitely in my mind when I'm using a French keyboard. There are not just flat rectangular keyboards, of course. People have designed many other kinds of things that are a lot of fun, and I just did a Google image search for unusual keyboards and came up with these, lots of different ones. I don't know how good they are. Some of them are purported to be ergonomic. They bend your wrist less or cause less strain. The one at the lower right is actually not a physical keyboard at all, but it's a projection and with a camera, and it can detect where your fingers are with respect to the grid that is projected by an image display there. But again, the concept is generally one input per one key. But of course, you know that that's not really what's happening. For a keyboard connected to a computer, there really is something going on more than just a physical connection. When you type a key, actually the operating system of the computer gets an event. It's an event that tells something about what has happened. If it's a physical keyboard, it might get a code which says the device and what place on that device is. So it might be, for example, when I touch the A key, I get a code that says I'm in row C. If you go at ABC row and position 0, 1 in that row. And then it would also have indications whether some of the modifier keys have been typed or held at the same time. It also can record whether the key was going up or down or was being held. And that information is much richer than a physical key being typed on a physical typewriter. But that data from the operating system is then fed to a keyboard driver program. And that driver program simply says, given this information about the event that occurred, look up a character based upon the key code and other information and send that off to whatever application currently has the focus. And so we think of clicking in a window, then typing in that window. That clicking in the window gives the attention, and the keyboard driver program knows to send the character or characters that were generated to that application. That keyboard driver program concept, something in the middle there, is one of the most important concepts of today, because that gives us the option of doing other things. Now, for English, we tend to think that the standard layout on most keyboards is the only one. Well, of course, that's not true. It just happens to be based upon the most widely used physical keyboards that were built over 100 years ago. But one of the things about those physical keyboards was that the keys would tend to jam if people typed very, very quickly. So people have come up with different arrangements. Dvorak is one of the more common ones, and you can see that the home row, AOEUI, is different than our standard keyboard, and that's because many people believe that the Dvorak model is more efficient. People have the most frequently keys on the home row and the keys that are more often used on the stronger fingers. My younger son, when he was learning to type, switched his device to a Dvorak keyboard, and I couldn't type on his keyboard, but then he couldn't type on mine either without doing a mental reset. There's another one called at the lower left, which is a QWERTY keyboard. And QWERTY is, of course, the QWERT row, starting on the second row there. An international keyboard may have more options. I tend to think of my keyboard having two options I use all the time, the base layer and the shift layer. But an international keyboard and other kinds of keyboards will often use the Control or the Control-Alt or Control-Alt-Shift to select many other characters. And the international keyboard that's shown here actually has alternates for covering most Western European languages, and including symbols like the pound currency symbol or the euro currency symbol. And so for many people who type English but also need other Western European characters, an international keyboard is great. There's another non-QWERTY based keyboard. It looks a little similar, it starts with QW, but it's Comac. And again, it's a multilingual keyboard, includes lots of things. And like any tool, when you get a tool that you like and you know how to work with it, your fingers learn very quickly where these are, and so it becomes very natural. It's also important to point out that many of these keyboards can be downloaded from many sources. Some are built into Windows and Mac already, but if you want another keyboard, very often you can download a file, install it on your computer, and that will be added to the repertoire of possible keyboards. And then you need a way of selecting the keyboard that you want. Here's an example of a keyboard that's producing a non-Latin character base. I work with the Cherokee Nation, and the Cherokee folks have a larger character set. They have about 85 characters uppercase and 85 characters lowercase. And a physical keyboard can be set up to type Cherokee. For example, in this particular case, you can imagine a keyboard driver. If it's set to use a table, which is down at the bottom here, the table can convert the particular key codes, the particular positions on a physical keyboard, into different characters. And these characters are shown here with the Unicode values, and then in parentheses, the actual shape of the character is shown in the Cherokee syllabary. And so Cherokee can be typed on a keyboard. If you install this keyboard driver program with the Cherokee lookup table there. It generates codes, which are then sent to the application program, and a Cherokee font, if that is installed and applied to that text, will produce the appropriate character in the Cherokee language or in the Cherokee writing system on the output. So this connection between physical key and what you see on the screen is very flexible when we introduce the keyboard driver and the lookup table. It's also important to note that because these are driven, or these keyboard driver programs accept events from the operating system, you don't really even need a physical keyboard. You might be able to use your mouse. Imagine bringing up a keyboard like at the lower left, a Japanese hiragana keyboard. The hiragana is a small set of phonetic characters, and people can either click them with a mouse, or you can imagine that when this keyboard comes up, it changes the keyboard driver program to say any physical keyboard inputs match what is shown on the screen in that little image. And effectively, I get a hiragana Japanese input keyboard when I bring this piece of software up. And the picture is basically a way to remember where each of those is for me. You also may have used things like Google Translate when you are using a different language for input, such as French. It can bring up a virtual keyboard on the screen and show you what characters there are that you're typing. And this is an example of the Azerty soft keyboard being used in Google Translate as its input. And again, no physical keyboard is really required. One on a touch screen, one could actually touch that keyboard and use that the positions of the screen on that, because the events are coming in to the operating system from either a mouse or a keyboard or a touchscreen. Well, since I joined Google in 2007, the world has changed. That's the year that the iPhone and Android phones were announced. And all of a sudden, the world went from having a very few people with advanced phones and basically computers in their pocket to a possibility for almost everyone in the world to have a smartphone in his or her pocket. And that is the situation for many people around the world. It's happened very, very quickly. A keyboard, in this case, is really just a special application. It's very similar to the keyboard driver that you saw earlier, but it has to do a little bit more. First of all, a keyboard for a touch device like this has to draw the physical layout. And usually it's drawn like it would be a physical keyboard, but it's often done with fewer rows and fewer columns. Why? Well, because most mobile screens are small and people's fingers are bigger than very tiny keys that you would need, or key areas that you would need if you drew a full physical layout on the screen. So very often a restricted set of characters is shown. This happens to be an input method for a language called Taipake. It uses the same writing system as the Burmese language, but they use different words. They use different sets of characters for their words. And so it is not the same as the Burmese input. And it has the characters that are most often used on a base layer. It has a way to go to a shift layer. It has a way to go to a numeric layer and symbols layer, just as many of the soft keyboards that you would use on your mobile device have already. Since it's a program, there are many, many options. Gboard is something that's built into most Android phones. iPhones have their own input devices, but almost anybody who has a little bit of programming experience can build their own keyboards. There are developer platforms available for both Android and iPhone, and people can build their own keyboards, put them into the online stores. And if you go to Google Play or the App Store, you can find zillions of different keyboards for many, many different languages. And because it's a soft keyboard, it's also particularly easy to pop up what we're pretty much all familiar with about using what you have typed in a previous word or series of characters and offering predictions or offering spelling checking, because there is physical area that is easy for people to see and then touch to make typing easier. So this has been a great advance and allows great flexibility. the concept of a physical keyboard has changed quite a bit in the last couple of decades. This is something that Tex reminded me about. A layout, in other words, where you put the individual things that a user will select for a particular language's input, is indeed not obvious. The placement of characters, as we've shown, can be flexible. QWERTY is not the only way of arranging the characters even for English. Why is that important? Well, people learn different ways. People have different opinions. And every language, of course, isn't based upon even the sounds that are in English. Many languages don't have the sound of R or the sound of Z that English does. And so those characters wouldn't be very useful. And in fact, those characters might not even be in the writing system. So when you're designing a keyboard, you have to understand several things. First of all, what writing system is being used. If it's using a Cyrillic writing system or a Greek writing system, it might be using the Burmese character set, or it might be using a writing system like Adlam, which is used for writing a language of Africa or languages of Ethiopia. Many, many different writing systems are available. All of those writing systems will have what we would generally call letters. In cases, there's syllables that include both a consonant and a vowel sound, or they might be an ideographic system like Chinese or Japanese or Korean, where there are many, many characters that have to be referenced in different ways. Many writing systems use diacritic marks, and by that I mean accents, umlauts, other marks above, below, to the right, to the left, or multiples of those to change the way the letter is interpreted. One you might be familiar with is French. When French type, or when the letter E is put into a French word, it has the sound E. When you type an accent on it, it all of a sudden becomes an A sound. So the diacritic mark is essential. As my German teacher told me a long time ago, it's not just a typing mistake when you forget to put an umlaut on something, it changes the word. So the diacritic marks are essential, and one has to plan how they are going to be added to the characters or included in the characters that you're outputting. In addition, people don't just type the letters or syllables or symbols for their words, but they use punctuation. Different languages use different characters for punctuation. In fact, in the Arabic world, the characters for the question mark and the comma and the semicolon are actually mirrored because they have a different shape, because the text generally flows from right to left. Other people or other languages use things other than our double quotes for putting things in quotation marks, and there's a wide variety of symbols used for that. People use numerals in many cases, and we think of 0 through 9 as the numerals we use. But of course, in different parts of the world, they have different numeral systems, and they need to be represented. Currencies are really important. And so on the QWERTY keyboard on Shift 4 is the $sign. But the $sign isn't going to be quite so important in England or quite so important in Greece as the other symbols for currencies. In India, you might need the rupee sign, which is the first one shown in this list. Nigeria, you might need the Nigerian currency symbol, and the euro, the symbol here for the Turkish lira, and others are used widely. And you have to decide not only where or what symbols you're going to put, but where. If you're in England, it's probably more likely that you will use the pound sign than the $sign. You want to make that more convenient. So when you're thinking of a layout, you want to figure out what's the relative frequency of each character in the language. You want to put the characters that most people are going to use more frequently on a layer that's easy to access and generally on fingers that are strong. If you're designing something from scratch, you have a lot of flexibility for that. But if you are designing for a language where there has been a colonial language, such as French in the country, and many people also speak French in addition to a native language, then you might want to consider using the French layout, where the keys are. My contacts in the Democratic Republic of the Congo, DRC, they have French as the dominant language there, and they asked me to build a Latin-based keyboard for the Hundi language that started with the positions of the characters as in the French keyboard, AZERTY. It's also important to understand how many layers you need. Some writing systems, some alphabets are very small. They might have only 20 characters. They don't need more. So you don't need more layers for your letters. You can use the shift layer for your numbers and your other symbols, or you might need to have more layers, such as your default layer, your shift layer, your shift control alt. Sometimes you might even need to use the caps lock. And then deciding which characters are in each layer is dependent upon how often you expect the characters to be needed and how easily you want people to access these characters. There is a document here which I'll reference, and you can look up this by looking for SIL and keyboard layout design, and you'll find it by a man named Martin Hoskin, who's done a lot of work with languages, many of them in Asia and Southeast Asia. And he has quite a nice document about keyboard layout, and especially he talks about large character sets for large keyboards. He talks about how you check the sequence of characters because the order in which you type them may matter, and actually talks about many of the implementation details, particularly of keyboard or at the state of input methods 20 years ago. I think this document is not up to date because it doesn't really talk about soft keyboard or touch keyboards very much, but the ideas here about thinking about the language, thinking about the characters that are needed, and working with the community to figure out where the characters should be on what layers is a really important step in any design. As I've indicated, the script matters. In many characters sets, such as Cyrillic or Arabic or Latin, there's a relatively small number of characters in the writing system. And I've shown you a virtual keyboard for the Adlam writing system, which is used in Africa mostly to write the Fafulde language, or also called Fulani. And it is an alphabetic system. It has upper and lower case, and it has a relatively small number of characters. You can also see in the top row of the virtual keyboard the digits 1 through 9 and 0, but they are not Western ASCII digits. They are Adlam digits. The right to left part is generally handled by the operating system and by the properties of the characters. A character in Adlam has a property that says it goes left to right. And so that information is used by the operating system or by the application, or in this case, by a browser, to note that the characters need to be drawn in a particular way when they are added. I want you to ignore this thing. I didn't take it off of this slide, but the point on this slide is that many writing systems have a fairly small number of characters that you can use with positions for each character, and in many cases, by adding diacritic marks such as accents, umlauts, characters that modify it as separate keys around the outside, you can support many languages that use these systems, which are usually alphabetic. But there are other writing systems which are medium-sized. As I mentioned, Cherokee has 85 characters uppercase and 85 characters lowercase. It is called a syllabary because each one of the characters in this table at the lower right is actually a syllable. So this line that's marked with M and the column that's marked E, that's the may, and may lowercase, may uppercase. This is me, this is ma, mo, mu, ma. Ma, me, mi, mo, mu, ma are the 6 vowels. And for most consonants, all of the vowels have a special symbol. The phonetic table can be used to build what we would call a phonetic input method. So here, this is a phonetic keyboard. People don't remember or have to remember where the 85 characters are in this keyboard. They just have to know the sounds and the corresponding Latin or English letters that are used to represent them. And this is good for people who are bilingual in another language. So if I want to type the characters sa, la, gi, which are the characters for the name Cherokee, I can type on this keyboard TSA, that turns into the sa character. I type la, and that turns into the second character. And I type gi, which gives me this character that looks like a Y. And this is done not through one key to one character, but the idea that a key produces a character which is remembered by the keyboard driver program, and then keys following it can modify that. There are sets of rules in this keyboard driver program that say, oh, if I see a T followed by an S followed by an A, produce the character sa. And sometimes when people are using a phonetic input method, they may actually see the characters change as they type in multiple characters in the phonetic input that actually define the output character. And people get used to this and can type very rapidly. I have a Cherokee friend who actually uses a phonetic input method. He's quite fluent in the language. He knows the Cherokee syllabary very well, but he finds the phonetic method much easier to use than a full keyboard that would have actually 4 different layers, and he would have to remember all of those 4 layers for all of the characters, lowercase and uppercase. Canadian syllabics is another one, and the syllabics are really interesting characters because they change position and add dots to represent the different vowel sounds, but the same idea. Very simple input in a language that is, or a character set that they probably know already, lets them phonetically determine a much larger set of syllabics characters. And this is used, for example, in the Cree, some of the Cree languages of Canada. Then for very large scripts, and I'm not an expert at this at all, but Chinese, Japanese, Korean, and a few other languages have very large character sets for their writing system. In the Unicode standard now, more than 95,000 characters are actually Chinese and or Japanese in the Unicode standard out of 150,000 characters roughly. So building a keyboard to represent that many characters is tricky. And in fact, even developing a phonetic keyboard that will let you type in a few characters and then determine exactly which of those many characters you want is going to be difficult. So in the case of these with very large writing systems, you can actually think of your keyboard as being, instead of just a keyboard driver program, it's often called an input method editor, or IME. And there may be 2 or more steps to determine the character, not just to describe the character, such as by its phonetics, or by its shape, or by strokes, or some other way of specifying it. But once the character is described with some things like the phonetics, then a set of options is presented, and then a person can select them either by touching or picking, in this case, the numerals 1 through 5 to indicate what character or characters are to be selected. Japanese is particularly complicated. It's one of the most complicated writing systems in the world because they don't have one way of writing their language. Almost everybody uses 3 different ways. Kanji, which are the ideographic characters, and hiragana and katakana, which are both phonetic input methods. So designing keyboards for Japanese gets interesting because many times people will type in one of the phonetic methods but expect the output to be turned into a particular kanji. And many of these options are available for mobile devices. So if you go into the App Store or Google Play, you'll see zillions of different input methods for these and other languages. There are 2 terms that are important to understand with building keyboards, and they are related to the physicality of actually entering a character. And they apply mostly to characters in Western languages or other languages that use base characters plus a diacritic mark. There's a concept called the dead key. And this is when a person would type in, for example, E with an accent on it in French by typing the accent first and then the E. And it's called a dead key because on a physical keyboard for French, typing an accent character would actually put that accent character on the paper, but then not move the physical placement for the next character, it would prevent that physical motion. And so the next character, like an E, would be typed under that accent mark. And it's called a dead key because there is no motion of the carriage of the typewriter. And more than one diacritic mark could be set up, but the physical keyboard itself makes these characters dead in the sense that they don't move when you actually type them. And that allows combinations of characters. It isn't perfect, but it allows characters to be added above and below a base character. And many input methods simulate this behavior of physical keyboards and have extended that to use the concept of a dead key. One of the disadvantages of a dead key is that you might not see any output until after the base character is typed. And in the case of the French keyboard, it turns out that some of the keys are actually already there in composed form. For example, an A with a grave accent is on one of the top row characters. The E with an accent is on one of the top row keys. But if you want to type an O with a little hat or a circumflex over it, you have to type the circumflex first and then the O to type hotel, for example. So there are things that are mixed between what are called pre-composed characters and dead key usage. In that article by SIL that I mentioned earlier, Martin Hoskin also defines what's called operator keys. And operator keys is kind of the inverse of the dead key model. It's the idea that you add a combining diacritic after the base character is entered. Now you can see that if that were used on a physical keyboard, one would have to type an A and then backspace and then type the accent on it. But on an input method or a computer keyboard, it's easy to say that the accent key following an A will know how to put that accent over the A as a combining mark. And it turns out that in the Unicode standard, when you have base characters, almost always the modifying characters, the diacritics or combining characters are added after that base character in the sequence of text's characters. And so the Enye character in these two models would be entered in slightly different ways. Either can be implemented in the keyboard building methods that I'm going to describe coming up. I'd like to give you one example of a method that I recommend for actually building keyboards now. It's not the only way. One can find some open source and some keyboard developer tools that cost money for various devices. Keyman is something that's been around quite a while. The man who built this actually started this work when he was a teenager. His parents were missionaries in Laos, and his parents came to him and said, "We need a way of typing the Laotian language." And he said, I could probably hack together something that would change your Windows machine to type the Laotian characters rather than just English characters. He happened to be Australian. And from that has grown a company, Keyman, which is now part of SIL. And Keyman is something that can be installed on your own computer. It consists of two parts. Keyman itself is an application, which is really just that key driver, that keyboard driver, that thing that interprets the events. And then there are definitions of the keyboard layouts that you want. Then Keyman also has got this open source and freely available program called Keyman Developer. And you can go to keyman.com and look for the developer. And it is a tool that works on Windows machines. I've not gotten it to work on my Macintosh, but so I purposely bought an inexpensive Windows machine to start using Keyman Developer several years ago. And it allows you to bring up a layout, which is very similar to the physical layout on the keyboard that you see here, or that you see on your laptop or desktop. And it allows you to simply click on a place, type a character that you want to be on the display, and type the character output that you want. So if we look here, this is an AZERTY-based layout. The key has a name. It's called Q. The KQ key has the character A as what would appear if you saw the visual representation of this. And down here, you actually say what the character that's output is on a particular character. So it can have one or more output for each of the physical places. And so this is a lot like designing a physical keyboard. One can touch the shift button here and you see a different visualization of that shift layer, and you can set up your characters as you like. So this allows shift, control, alt, caps lock. It allows effectively 8 layers or more to be used. If you use different right control and right alt, you can get a lot of different layers. And this is great for defining something that would go on a desktop or laptop because it maps directly. There are some keyboards that have one more key, a slightly different arrangement, generally in the layer where we would see the Z, this layer above. And so Keyman offers options for different physical keyboards. And when one has defined a keyboard here, one says compile. The compiled file is then something you load onto your Windows or your Mac or your Linux computer. And if you have the Keyman application installed, the Keyman application can then switch to using the new keyboard that you have defined. I built this for the Kihundi language, the people in Africa, and they are very happy with it, but they would prefer to do the thing I'll describe in just a moment. It is important to note that from that Keyman physical layout, or the layout picture that you saw, what's actually being generated is a set of Unicode characters based upon the positions of the actual keys. So this is sort of the physical description of each key. The K codes define the physical positions that would be on a QWERTY device. So KQ describes that row and column on the physical keyboard. And in English, the content of the KQ key would be the lowercase q. And for the Hundi, we would make that into an A because it's Azerty based, and they would have different outputs. And this is just part of that table, which is actually generated when one builds a layout. It's also possible to add rules to this. So you can say that you would like to have combinations. If you say that I type an A and then type an acute accent after it, this would be the operator mode of input, then it can combine those two into another Unicode character that is the combination of those two, because Unicode does have some pre-defined character combinations. And when you're actually building something in the picture form or in the graphical design, what's actually being put together is this data file, which is just text describing the characters that you're working with. And you can examine this. And in terms of most layouts, this is pretty simple to look at, but I prefer to actually build the layout with the graphical display. But for some more sophisticated things, such as adding rules, actually editing this design in the code is the best way to create the more sophisticated behavior that can't easily be represented by the graphical display. Now, my friends in the Hundi community want to use a mobile device with their language. And it turns out that the Keyman Developer has been extended to not only output for Mac and Windows and Linux, but also can build a touch layout for Android, for iOS. It supports phones, it supports tablets, and various sizes of those. So this is the touch layout editor, and it's very much like the one we saw before here. And it has the options of saying what the key will show when it is drawn on the screen, and it indicates what layer you're editing here. By default, there are several layers, just like in the layout for desktop or laptop, but one can make as many layers as you want or delete layers that you don't need. So very often there is a layout that is for lowercase, another one for uppercase, a third one for numbers and some symbols, and a fourth one for other symbols that are less often used. And these are definable with this layout. So given a particular key, you define it on a particular layer, you say what it's going to be, you say what its identifier is. So this is basically saying this is the Unicode character for lowercase a. But the ones that have the little diagonal mark on the upper right also have the concept of a long press with it. So for the A, they wanted to have various diacritic marks that were added to this. And so this allows one to add long press, and more than one long press can be added for a particular one. This particular character has these 6. And again, one can go look at the text code for this and make more sophisticated changes there. But this visual way of describing a layout for a mobile device is really nice and lets you see what's going on very quickly. The important thing about mobile, as I said before, is that you want to have fewer characters in the width and the height on most mobile devices, and that's why you need more layers. And then these keys to switch the layers, I'm sure you're familiar with, are very important. So this switches to the uppercase, this switches to the symbol or to the numbers layer, and then a symbols layer can usually be selected from there. And often it's useful to add a key which lets you change to different keyboards, because many people have a dominant language in their country that they use and need to switch to that. So in this case here, if a person is using Keyman with the Hindi language, they might want to switch to the French keyboard. For other types of things they want to do, that key can be programmed to do that as well. The punctuation can be put here. This one includes accent marks. The accent is a combining accent. This accent is a combining mark that goes over. This accent is another combining mark that goes over. And then the different layers allow people to type nicely in Hindi. It's also possible in Keyman to test your mobile device or test your regular keyboard without actually installing it. One can say test on or in a browser, and then the browser brings up a visual display of what you defined, and the person can touch with a mouse or even touch with a physical keyboard the characters. It will show the characters, the Unicode output, and one can interactively check out if what one has built is doing what is expected. It compiles to an output file, which is then available for you. So Keyman works by building a application that can choose among a number of layouts that have been defined for the particular device, whether it's on mobile or it's on a desktop. You say Keyman application and then pick the configured keyboards that have been loaded into Keyman, and then Keyman takes over the input methods or the inputs. So on my Android phone, for example, I have the Gboard as the default keyboard, but I can switch to Keyman for keyboards that I have downloaded from the Keyman website or keyboards that I have built myself using the Keyman Developer. And this lets me use a wide variety of input methods. And again, they all talk to the applications in the same way. Especially on a mobile device, this is really, really nice. But there are other tools. And just briefly, Microsoft Keyboard Layout Creator has been around quite a while. It's a way of building keyboards that work in a Microsoft environment, desktop or laptop. One can build keyboards. It works very nicely for alphabetic languages. I don't know how to do rules for phonetics in MSKLC, but it may be possible, but it is Microsoft specific. There are also Apple specific tools, and these are available for you. It's important to note that these keyboard developer tools can be used for characters that aren't even in the Unicode standard yet. So for characters that aren't in the Unicode standard, or they're brand new to the Unicode standard, if one has a font which has the relationship between a particular code and a particular character that's to be displayed, you can use that font, tell the keyboard, for these particular places on the output, I want these particular codes, assuming that the font will take the code and turn it into the right character on the screen using that font. Then you can use characters that are not yet in the Unicode standard if someone's developed a font for them. And this happens quite a bit. Many of the non-Unicode scripts are used by people happily on their desktops or laptops with the fonts. All they have to do is make sure that when they use the keyboard in an application such as Word or a text document, that they have selected the font and applied the font to those characters. Those characters could have codes that are new Unicode values that have not yet been made available on mobile devices, or they could be in what's called a private use area, which is an area that says you may put character codes in this particular range of numbers, but don't expect them to be standardized, but they will not overwrite or interfere with character codes for other writing systems. Or some people overlap them with standard areas, such as using an ASCII or an Arabic range of characters, and then they can use them with a standard QWERTY or a standard Arabic input method. And with the right font, they'll get the right output. These are steps that can be used before things get into the Unicode standard. And they work quite well. The output is less portable because the font has to be sent with the document that one is producing. And hence they do not work on mobile devices where the font can't be installed, or they don't work on social media where you put text up there and someone else doesn't have the font on her machine to see that working properly.